we are going to start our chapter number 2, that is about sets, functions and groups. Today our topic is sets in mathematics and its types. We will study. Okay, so in today's video what we will learn? We will learn about the definition of a set. What is a set? Then we will see how to represent a set and write elements of a set. Then we will see by how many ways we can describe a set. We will see different methods that we can use to describe a set. Okay, we will focus some famous sets that are popular in algebra, difference between equivalent sets and equal sets. Then we will see order of a set, and lastly we will see finite and infinite sets. We will see all the things one by one. So let's clear all the questions one by one. First we will see the definition of a set. What is a set? A set is a collection of distinct and well-defined objects. We use curly brackets like this, and in between we use element. We write elements, okay? And we use commas to separate the elements. Let me say the collection of first 5 natural numbers. First 5 natural numbers are 1, 2, 3, 4 and 5. Okay. Why I focus on these two words, distinct and well defined? Because if the collection is not distinct, the collection will not be set. For example, if I write as 1, 2, 2, 3, 4 and 5, this is not a set because the collection is not distinct. We have repetition of elements. Repetition of same element in a collection will not make it a set. Next we come to the point well defined. This was a counter example of this, and now we see counter example of well defined. Let me say the collection of interesting hobbies. Collection of interesting hobbies. This is not a well defined collection because interesting hobbies for me could be different and interesting hobbies for you could be different. The hobbies different from person to person. That's why this collection will not be a well defined. Okay. Next, how to represent a set. To represent a set we use capital letters usually. Okay, like A, B, C, X, Y, Z, capital letters. And to write members of a set we use small letters like A, B, C, small ABCs. By how many ways we can describe a set? We can describe a set by 3 ways. These are number 1, descriptive method, number 2, tabular method, and number 3, set builder method. In descriptive method, we express the elements of set by words. We use words to describe a set, okay? In tabular method, we directly put the elements in the set. We directly put the elements in the brackets to represent a set. In set builder method, we use a symbol or a letter for an arbitrary member of the set and state a property that is common to all members. I will show you all of these by an example. Consider in your mind the set of first 5 natural numbers. Okay, how I will describe it in words? Descriptive method, na? I will write the set of first 5 natural numbers. This will be descriptive method. The set of first 5 natural numbers. And then I will close them in brackets. This is the descriptive method. Okay, so next method is tabular method. In tabular method, I directly put the elements. I know the first 5 natural numbers are 1, 2, 3, 4 and 5. Okay, so this is the easiest way to represent members of a set. And number 3, we have to write it in set builder notation. That is mostly used in our examples. I will denote these elements by an element x, okay? The set x such that x belongs to n because x is a natural number and there is a condition upon x that x is less than 6. Okay, these are three notations to describe a set. Next we will move examples of sets in algebra. What are the famous examples? These are natural numbers, whole numbers, integers, even numbers, odd numbers, rational, irrational, real and complex numbers. Okay, we all know all these types of numbers. This is n and this is denoted by 1, 2, 3 up to so on. This is represented by w and is equal to 0, 1. If we put 0 in the natural number, it will become whole numbers. Integers, we know these are represented by z and negative infinity -2, -1, 0, 1, 2 up to so on positive infinity. Even numbers, we know this is denoted by e and is 0, 2, 4, 6 so on. Odd numbers, we know this is represented by o and this is 1, 3, 5 and so on. Next is rationals. These are p by q denoted by q equal to p by q, where p and q belongs to z and q is not equal to 0. I think this need not to be taught here. Q dash equal to p by q, p q belongs to z and q not equal to 0, and real is equal to q union q complement q dash. Complex numbers, numbers of the form a plus b iota such that a b belongs to r. Okay, these are very common. Next, question number 5, difference between equivalent sets and equal sets. Equivalent sets are those sets having the same number of elements and equal sets are those having same elements. The difference in these two definitions is this number. Okay, let's see how. In case of finite sets, two sets are equivalent if they have same number of elements. For example, consider the set 1, 2 and 3 and another set b equal to 4, 5 and 6. Okay, these two sets are equivalent because they have same number of elements. Set A has 3 elements and set B has also 3 elements. But in case of infinite sets, the definition is a little bit changed. Infinite sets, we have infinite set, consider integers 0, plus minus 1, plus minus 2 up to so on. We will say this set is equivalent to natural number. Any other set consider, say natural numbers 1, 2, 3. We can say that this set of integers is equivalent to this set of natural numbers if we can establish a 1-1 correspondence between the elements of z and the elements of n. Okay, I hope you will get my point. Next is two sets having the same elements, equal sets, in case of equal sets. For example, consider the same set A, 1, 2, 3. Another set B will be equal to A if B also has the same element 1, 2 and 3. Okay. Next is order of a set. What is order of a set? Order is number of elements in a set. Consider a set A is equal to 1, 2, 3, 4, 5, 6. What is the order of A? Order of A, we denote it by A, or we say as cardinality of A. Cardinality of A. We simply count its numbers 1, 2, 3, 4, 5, 6. Order of A is 6. Okay, this was the case of finite sets. What if we have a infinite set? Consider the set of natural numbers. What is the order of A? The answer is the order of A is infinite. Okay? Or we can say that cardinality of A is infinite. Cardinality of A is infinite. Next, our next point is finite and infinite sets. Okay, so first let's see what is a finite set. A finite set is the one which has limited number of elements. Limited number of elements. For example, days in a week. Days in a week. This is clearly finite. As we know, days in a week are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Okay. Next, infinite set. A set is infinite if it has unlimited number of elements. These two definitions are contrast of each other. Unlimited number of elements. For example, the set of natural numbers or the set of integers. These two are examples of infinite sets. Okay, so for today it's enough. In tomorrow's lecture we will learn about further types of sets that are proper set, improper set, subsets, etc. Till then, take care. Bye bye. Allah Hafiz.